Hello, welcome back to week 6 of our Fusion 2020 robot build. My name is Corey Alpwait, mentor of the Grand City GearHeads, Team 3244 out of St. Cloud, Minnesota. Last week I left you here with this chassis. We installed the 4 bearing block assemblies on the corners, and I gave you the task to go ahead and install the gearboxes at the center. If you're watching this video and you don't have access to our asset library, or maybe you're tripped up here, in this video here I'm going to show you how to go ahead and download that file from VexPro and configure it the way the GearHeads use the 3-sim gearbox assembly onto a West Coast drive. We do modify things a little bit and don't mount it exactly how instructed using the Versa block. We mount that gearbox directly to the frame rail. And since we don't use the West Coast style chain outside the tube and we put it in the tube, we also have not a modification, but just the third stage, not the West Coast drive third stage assembly. So moving on here, the first thing we need to do is go visit the VexPro website. I brought that up here, and along the top here we can go look at the different sub menus here, motion and gearboxes. Scrolling through the gearboxes, we see the 3-sim ball shifter that we use. And if we go down to the bottom of the page, past all the configurations, we have this menu down here where we can go to CAD files. And in here we can look at all the different CAD files that we can download. So the first one you see here is just the 3-sim ball shifter, just the motors and the gearbox. We use the second configuration here, where it's the 3 sims, the gearbox, output shaft, but no chain assembly for a typical West Coast drive. If you use the West Coast, you're going to want to download the third option here. And here you can see there's space available to install a double sprocket to drive your chains front and rear if you mounted center mount like we are today. So I'm going to go ahead and download the 3-sim ball shifter with third stage. And when that's complete, we are done here. I'm going to close this website out, and I'm going to start a new document untitled. And again, before we can import anything into our document, we must save it. So I'm going to save this one here in my folder, sure, as sample. Sim shifter gearbox. Next thing we need to do is we need to import that. But to do that, we're going to go ahead and upload. Select the files. Download the last one I download, or select the file that we just downloaded and upload this to the project. Alright, now that it's completed uploading to our project, we can close this window and now drag this into our new project. The first thing I like to do is rotate this in an orientation relative to the orientation cube here, how it would be mounted on the robot. We see the axle is pointing straight in the air, and I'm going to rotate this 90 degrees down. And I'll just lock it into place right here. So to make this more usable and so we can add our own motors onto it, I'm going to go ahead and delete the motors that I can drag out. You see I can't select anything these to edit or delete. It just exploded view. And that's because this is still linked to the source file. I'm going to go ahead and break the links here. Cancel, it'll delete. Break link. Hit continue, it'll just snap it all back into place. And now we should be able to drag these motors out. I'll do a group selection here and delete them. The other thing we don't use on the gearbox as it's configured here is the encoder assembly. We've developed find that in the project tree so I can select the whole assembly. We'll do some control selection of the components here. Change that to select component instead of face. These screws will go away. Washer and nut, and this large gear here goes away. And there's some other components, there's some nuts on the inside that will need to go, and we could browse or make these things transparent and get rid of them as well. I'm not going to waste the time here. I will though delete these pinion gears. If we browse in here a little tighter, you can see that this comes with every gear and every combination sold. And a good idea would be to go through here and delete the gears that you are not using in your configurations. This will just help computations later on. And if you wanted to find the part numbers, you could look up the part numbers you're using, look them up in the tree, and make sure you save those. So what we're going to find now is this part is, although it looks like it's assembled, you've seen how the motors, I can just drag and drop them and the parts can just fly all over. We're going to want to lock all that in place. We're not going to use individual joints, we'll use the group, rigid group. But before we do that, I'm going to make a couple more changes to the way these bolts are. We use these 4 bolts across the front here to attach this gearbox to the drive rail directly, as I stated before. Normally you'd put a Versa block, attach it to these 2 of these holes through the Versa block, and clamp it on like we did at the front and rear assemblies. Well, like I said, we use these 4 bolts to attach the robot to, or the gearbox to the chassis rail. So what I'm going to do is I need to move these out and simulate, like there's a to simulate the 100 thou tube that this bolt head clamps onto. I'm going to go ahead and select the move copy. Selecting bodies, I'm going to select this bolt and that bolt over there. If I look from the front, I can see I can move this bolt head out, and I'm going to manually enter in -0.1 to simulate that material that it'd be clamped onto. We also add a piece of angle iron to the top of our frame rail to capture this bolt up here. So I'm going to do the same thing with these two. Selecting the two bolt heads. First I'll select move. Drag that straight out. 0.1 of an inch. I'm not too worried about accurate simulation of all these axles and gears turning in time or with the ratio, shifting the shifter in and out. So at this time I'm going to go ahead and apply that group, the rigid group. This time I'm going to capture the position because I do not want these bolt heads to return back to their normal configured positions. Window select. Alright, let's window select it all first. Rigid group, capture position. All the parts are captured. Okay. So now that we have everything grouped together and moving along in its own assembly, before we lock this down, like we have with our other assemblies, using the as-built joint and selecting a component from the sub-assembly to the top level and locking it into the space, we're going to go ahead and get this component brought to something relevant to the origin of this workspace. And what I mean here is, if we go into the project tree here and we turn on the origin, we can see that the 0, 0, 0 point is kind of here in some non-relative position in space. And if we look from the top here, it's not lined up with this output axle like we might want it to be. It's not even output to the shifter. We want to line this up so the center line of this drive axle is in line with the x-axis of our view cube here. To do that, what we're going to do is click on the axle and go find that in our subassembly tree. You'll see it's underlined, that what's selected. If I expand that, I can turn on its origin as well. When this object was created, the origin was set up, spin around to the front, with the Y, X, this plane, and the Z of the axle along the length of the axle. So we're going to line the Z of the output axle along with to our X axis of our view cube here. To do that, we can use the modify, align, and it's going to be tough to go in there and select this, but we can use the origin of the axle and pick the Z as our from. In our 2, we want to lock it in to the X axis. Here I can got the X axis highlighted, or I could browse up to the top of the project tree, expand the origin there, and pick the X. And now you'll see, if I zoom out, look at it directly from the top, our axle is now perfectly in line with our x-axis, and from the side that way too. So now the 0 line is through that axle. I'm going to select OK. And before I move anything, now is when I'm going to want to lock this into place so it doesn't change. So now I can use the assemble as built joint. I'm going to capture this position because I don't want it to move back to where it was originally. I'm going to select the axle. Then I'm going to select the top level of this project. You can see it's locked into place. And OK. So now we have some origin planes that mean something to us. That the XY is perfectly through the center of that drive axle. The ZX is through that drive axle. Locked into place. So we don't need these planes anymore, so I'm going to go ahead and just hide them from us. And a quick way to get there sometimes is you right click on it, find in browser. It'll jump you to that, and if you have a lot of components in your project. And I'm going to hide that origin too. So now we can go ahead and start adding some components as we did with our idle bearing block assemblies. I want to view this from the front. I'm going to create a construction plane to draw some construction geometry on. Offset plane. I'll select the ZX plane. Remember, that plane goes through the center of this axle now. And now I can create a sketch on that plane. What we'll need to do is pick up some of these edges off this plate and build our 1x2 tubing profile on here. So I can use the project to project this face by either typing P on my keyboard, selecting, you can select bodies, or entities. If we do the body, it will select everything here. Either one works for this case. Next thing we can do, we can draw that rectangle. It's going to place it roughly in place. We'll add some dimensions. 1 inch wide. 2 inches tall. Should be able to drag that up. I want to drag. We'll need to know where the center line of this bearing is so we can dimension where that pokes through the hole. We'll project. Bearing. Okay. It's starting to get a little busy in here, so I'm going to try to hide this. And this axle for now. I'm gonna hide this bolt headed too. And try to get that to slide up, but for some reason she's not sliding. Okay, I had to pause there for a moment to find out why that was not selecting and dragging and moving for me. And what I found out here is somehow, I'm not really sure how, I lost my filters here. My bodies was the only thing that was selected that I could, or was the only thing here that's selected. And that might have been when I came up here and changed that priority up here. What I had to do is, I could go ahead and try to find the different things I want to select, but for now I'm just going to hit the select all, and now I can drag this feature around to place it a little bit closer to where it's going to be. Now this box will be we want this point to be coincident with that edge, to be flush up against it. And what we want is this bearing to be that 1/16 of an inch below the center line. So if we go ahead and create a point, and remember, this center line is through the center of that axle, and we can see that when I mouse over here, it's the center line of that projected edge from the bearing. I'm just going to put a point there so we can easily see what we're doing. And what I want to do is drag this slightly up, and I can make a dimension from this point. Holding the shift key, I can find the center line, the center point of this. What I can do is add a dimension from this point to the center of this line segment. There we go. And put that 1/16 of an inch in there. So now this axle is 1/16 of an inch below the center for our drop center. Well, that ain't right. 1/16 of an inch. Finish sketch. So now we have some geometry we can snap our bearing blocks onto. So now what I'm going to do